Hello, and welcome to the Scientific Adventures of Beardman. Today we're going to be talking about the scientific method and going through the 5 steps that I like to use when describing the scientific method. First of all, basically the scientific method is a system to solve problems. And it really can be used with anything that you consider a problem. It can be in a relationship with a friend or girlfriend or boyfriend, or in a physics arena. Okay, obviously chemistry or biology or anything like that. But really any type of problem between countries, anything, you can use the scientific method to figure out a solution. Step 1 of the scientific method is just to make observations. Now, observations are more than just what you see. They're anything you can observe using any of the 5 senses. So anything you can see, smell, touch, feel, taste, any of those things are observations. And every one of you has made billions of observations so far in your life. And so you have this great set of observations. If we look beyond that, our friends and family and strangers and people around the world have made quadrillions of observations in their lifetimes. And a lot of those are recorded, and you can find them on the internet, things that people have seen and observed. And so the first thing is to recognize that we have all these observations. After you've got a set of observations, both yours and others, then developing a question is important. So you're standing on the 2nd floor of a balcony and you wonder how fast things fall and what makes them fall faster than other things. And often asking good questions is one of the most important things in science because it leads you to something that's worth researching. Asking good questions is really an important part of the scientific method. Then we come up with an idea. Hey, maybe things fall faster when they're closer to red on the spectrum. So if I drop a red ball, it falls faster than a blue ball. First, we just hypothesize, which is an educated guess. So based on our observations, perhaps everything that I've seen that falls fast is red. Those are my observations. And so that's my education. So based on that education, then I might say that red balls fall faster than blue balls. And the closer you are to red in the spectrum, the faster things fall. And that's where, in the old days, science would have stopped. If you have brilliant people like Aristotle, Socrates, that wrote tons of stuff about all kinds of things, that's what they did. They gathered all their observations, they formed a question, and their hypothesis was really their final answer. They spent a lot of time thinking about it and did a pretty good job. But it wasn't until about 400 years ago when somebody kind of made this popular. A guy named Galileo Galilei made popular the idea of running a test or an experiment and saying, hey, it would be easy to figure out if red balls fall faster than blue balls. Let me just take a red ball and a blue ball up to the top of a building and drop them. And he did. He's most famous for dropping them off the Leaning Tower of Pisa. Although he wasn't using red balls and blue balls, he was using larger and smaller and all kinds of different things to see how they fell. And so that experiment would be designed in order to test your hypothesis. Now, as you do your experiment, it's important to develop a detailed description of what you're going to do. We call it a procedure. And because that experiment needs to be able to be repeatable by other people, so that after you drop your red ball and your blue ball from a certain height, and you measure how much time it takes them to hit the ground, or you just compare the two, then somebody else, somewhere else, could take the red ball and blue ball and see if you've done a good job in your experiment, and they could test it and see if they get the same results, and therefore give validity to your experiment and your results. Now after your experiment, you may find that it wasn't true. If I drop a red ball and blue ball, they're going to fall at the same rate and hit the ground at the same time. The color of the ball has nothing to do with how fast they fall. And I would find that out by doing an experiment. At that point, I've gained more observations. My current hypothesis is no longer a hypothesis because it's no longer educated, okay, because it contradicts observations that I've made. Okay, and so now I need a new hypothesis. Okay? And then we might get into something that deals with air resistance and get to why some things fall faster than others through air. Okay? And once we've done that and done the experiment repeated times and our hypothesis can predict what will happen, that's a key word, that your hypothesis can predict the outcome of the experiment. Once it can do that repeatedly, then we can kind of launch that idea into either theory or law, depending on what we were testing. Okay. And so theory or law is that set of things or something that many people in many places have experimented and been able to predict using that idea, and it's come out accurate every time, and therefore we now have a theory or a law. And that's the basic idea of the scientific method. You can apply this, like I said, to anything in any relationship or any scientific idea or thought or how anything works. You can go through the scientific method and be able to come to a conclusion that is the best that's possible based on the current set of observations. Which is a good thing to mention. Even once you get to calling something a theory, it's still the best explanation based on the current set of observations that we have as humankind. If someone does an experiment that creates new observations, it could be that they'll contradict it and we'll have to revise the theory or throw it out. But that's what we're learning, is the things that for however many hundreds or in some cases thousands of years have continued to never have been disproven by anyone's observations. The 6 billion people or 14 billion people or however many people have lived in the course of Earth's history. So once again, that's the scientific method. You recognize you've got observations or make some new ones, then come up with a question, something that you're going to try and figure out, then come up with a hypothesis, which is an educated guess, educated based on your observations, meaning it does not contradict your observations. Then you do an experiment to test that in a controlled setting, which isn't always available just in nature, a controlled setting where you keep all your variables constant. And then finally, if it continues to be able to predict the outcome and it continues to do that time after time, we start calling it a theory. All right, we'll see you next time on Scientific Adventures of Beardman.